we gotta understand this. I think this will help a little bit because that's the two things that are added at the end of our CS and SS registers. Oh, yeah. It told it. That's what I was expecting. All right, all right. So we read this yesterday, so let's read this today. Will I make it? Who knows? The Intel 64 architecture protection architecture. Oh fuck, we already read this. We're reading it again. The Intel 64 architecture's protection architecture is based on use of 2-bit privilege level 0 to 3. Operation at a particular privilege level is informally called a ring. Thus, ring 0, the most privileged ring, refer to operation while the current privilege level is 0. While, okay, CPL, current privilege level, let's keep that in mind. While ring 3, the least privileged ring, refer to an operation while the CPL is 3. The Intel 64 architecture defines a number of control flow transitions that change the CPL, known informally as ring transitions. There are two principal types: transition that increase privilege by decreasing the CPL. These include transition using interrupt trap gates and trap gates in the interrupt descriptor table, execution of the far call instruction that access call gates, and executions of the syscall and sysenter instruction. Transitions that decrease privilege by increasing the CPL. These include executions of the instruction I return, far ret, sys exit, and sysret. In IA32E mode, which is the mode that everybody runs in, the CPL is visible to software in the RPL field, requested privilege level of the segment of the code segment selector. Okay, can we have like an accounting of this shit? What the fuck is this? Okay. Am I going to the same thing? I may be. No explanation? Okay. Okay, segment registers. Cool. Better description. Hold the code segment in which your program runs. Changing its value might make the computer hang. Okay. So this is a pointer to the code that we're executing, I guess. Or is it like where we are within our code? That would be the same. Oh, so CS would be automatically incremented each time we run an instruction, right? Can I? Okay. So as the question states, what's the purpose of CS and IP register in Intel 8086? The physical address is calculated from two parts: segment address, offset address. The CS code segment register is used to address the code segment of the memory location in memory where the code is stored. The IP instruction pointer contains an offset within the code segment of the memory, and CS, which right after IP instruction pointer, is used to point to the location. ACS and HCS. I have no fucking clue what you're talking about. Nope, I don't get it. But I get the pointer thing. Okay, but do we still have the IP register? Ah, okay. How do we calculate that IP thing? Oh, rip. Okay, but that's a little bit retarded, no? So you're saying that you're doing the 16-bit thingy to point to where in memory, and then you add 64 of it in order to point precisely, and it's this one that's getting incremented each time? I guess so. I guess so. Okay. It makes sense and it doesn't make sense at the same time. Okay, cool. Stack segment. What the fuck is this? All the stack segment your program uses sometime has the same value as DS. Changing its value will give unpredictable results. Okay. Shit. That is an understatement. Are we talking about the comment about how it will break things or that we're fucked? What's the difference between ESP register and SS register? ESP register is a 32-bit version of the SP register, but in 32-bit architecture, SS is irrelevant. So let's talk about 16-bit first. Note that okay. SS, what the fuck? Okay. About the unexpected result by changing the stack. Okay, makes sense. I should make a compilation of you looking clueless. What the fuck is this? I don't know what I'm doing here. I'm so fucked. Bro. I love you, Sam. Yes, that would be funny. You hit the nail pretty straight on, okay? That's no gay joke on there, but that was pretty straight. SS is the stack segment register. It identifies the block of memory that will be used for the stack. Okay, why? Okay, stack pointer register. It points to the precise location within the stack segment, which is at any given time the top of the stack. Ah, okay. I get it now. The 16-bit Intel architecture had a clunky mechanism for implementing a 20-bit wide addresses by means of a 16-bit segments plus 16 bits offset, so the SS register would point to the stack segment and the SP register would hold the actual offset into the stack. We would say that the current stack location was an SS followed by SP. Okay. Yeah, makes sense. Naturally, you might be wondering how comes they were only able to have 20-bit wide addresses instead of the 32-bit address, given that the segment register was 16-bit wide and that the offset register was another 16-bit. Well, this is because this is part of why the architecture was clunky. The actual address represented by SS-SP pair was not calculated as SS offset 16 SP bit shift. Instead, it was SS bit shift 4 plus SP. This means that the segment had a very high degree of overlap. Oh shit, that's kind of retarded. Even though each segment was that amount of bytes long, its start was only 16 bit away from the start of the previous segment. So the segment offset address 00 represent the absolute address 0, while the 10 address represented the absolute address 16. Apparently, they did not believe that anyone would ever need to address more than 20 bits of address space. Okay. Yes, and we would connect those to the chatbot and make them appear from the chat. Bro, my favorite thing to do is to take people's video, cut out just the pauses. You can see who they really are. It's kind of creepy accurate. I mostly look retarded if that's the case. Yes, x86 segment offset has been weird since the beginning. Yeah, okay. Yeah, but the SS register is probably still used. While segmentation mostly disabled. Ah, okay, so we don't even use all of this probably. Okay. SS control privilege level and is relevant during mode switches and system event. Ah, okay. Okay. Okay, so I guess that doesn't matter for us. So if we go and check here, we can essentially assume that when they talk about, wait, is CS part of this? Like, is CS a thing that we're not using anymore? CS plays a critical role in determining the base address in the instruction for instruction fetching in 64-bit mode. CS base is generally treated as 0, and segmentation for code segment is largely disabled, allowing a flat memory model for code execution. However, CS remains essential for defining the current privilege level, okay, influencing protection and privilege check. Oh my god, okay. Petting my cat with my foot, and she's purring very loudly. Fair. Okay, so essentially, all those are fucking useless. Oh no. Well, useless in their original way. Oh my god. So they're just configuration switches based. Okay. So now this makes more sense, right? Wait, can we have like an accounting of what the fuck this is? Oh, why would it? It will just put the thing. Okay. Forget what I said. I'm retarded. Oh, okay, that's 32-bit. Let's not look at this. Oh, okay, that's why there's no if-def, is because it's a union. We don't actually give a shit about if your computer has it or not. Okay. Are we saying that all of this is within, that's like saved at the bottom or top of the stack? No, that's a trace thing, so it's just, fuck. Maybe that would help. x86, 64. What information is on the stack? The stack is a FAFO type of data structure called fuck around and find out. Okay. Okay. So, brain. Okay. Not important. How does CPU stack work? Whenever you enter a function, pass argument to this function, declare a local variable, or leave a function, the stack is used by the CPU in one way or another. In order to be able to explain the code, we need code. So here is a small program written in C that sums 3 integer on the left of the C code, and on the right is the assembly code after compilation. Okay, cool. So let's say that you are in main. Why do I have... My screen is fucking up. Okay. Let's say that you are in main function, about to call the function called sum. You pass 3 arguments to it. Int a, sum 10, 20, 30. In low-level assembly instructions, it will look like this. Okay, so, oh shit, cannot... Wait, what? Ah, okay. Those, cool. So move, EDX, ESI, EDI. And what are those? Can I have my fucking CPU somewhere? Bro, I'll eat lead. Okay. Data sort. Oh, okay. So I guess that those are like um free to be used things because they're general purpose. Cool. Got it. Finally, main will issue the subroutine call instruction call sum. Call sum. Okay. When the call instruction is executed, the value of the RIP instruction pointer register is pushed onto the stack, which essentially saves the address before entering some function, to which the program should return execution after leaving sum. Okay, makes sense to me. The state of the stack is currently looking like this. So we have data, and we have the return. After the call instruction, the RIP is redirected to the address of the function sum. As you can notice, the 3 arguments are moved to 3 32-bit general purpose register. Okay, so they follow that way. You are now in the sum function. In the first thing that happens on the CPU level is creating a stack frame. This will be a portion of the stack that will be available only for the current function. Whenever the function returns, this stack frame will be destructed. deleted maybe. In sum, the very first instruction that will actually prepare the stack frame are push RBP, move RBP, RSP. What this does is to save the current position of the base pointer, the bottom of the current stack frame, and replace it with the stack pointer, the tip or top of the stack. I'm trying to get through this, okay? I swear I'm not trying to be fucking bad at reading, but it's hard today. Okay, so the new base pointer is the current top of the stack. This operation of saving the old base pointer and moving it to the tip of the stack is called function prolog. I'm fucking confused. RBP. What is RBP? I'm confused. Base pointer. Two times the same thing, and I'm just retarded. After call instruction, the rip is redirected to the address of the function sum. Okay, so that's for the instruction. As you can notice, the three arguments are moved to 332-bit general purpose register. You are now in the sum function. So that's for the instruction. Okay. The first thing that happens on the CPU level is creating a stack frame. This will be a portion of the stack that will be available only to the current function, for the current function. Okay. Whenever the function returns from the stack frame, whenever a function returns, the stack frame will be deleted. Does this guy doesn't have like comma where I would put some? Is that the problem, or I'm just sleepy? Probably just sleepy. In sum, the very first instruction that will actually prepare the stack frame are RBP and RBP. Okay, so push on the frame, RBP. Okay, what this does is save the current position of the base pointer, the bottom of the current stack frame, and it replaces it with the stack point. So the new base pointer is the current top of the stack. Oh shit, I think I get it. Okay. So, oh, okay, this is the only... Fuck, we need this. I need to be able to zoom into this. Okay, thank you. So, shut up. Go there. And can I, like, move this, or am I fucking retarded? Okay. So, this is the stack for sum. And here what we save is the instruction for whatever the fuck main is, so that we can go back to the instruction, not stack instruction. Now we need to also save, whenever we're inside of sum, the address here for the old stack, so that we can return to it. Because right now what we have saved is the sum stack, but we don't have the position of the main stack saved. I think I get it. The stack frame. The stack frame is the gap between RBP and RSP. In our example, the only thing that is in the stack is the old RBP value. So the stack frame looks like this, okay? Kind of confused about what they're talking about. I guess when they're talking about the frame, they're talking about the whole thing instead of just one stack. However, we have three arguments inside registers that are used as argument to the function sum. To use them, the compiler generates code that will save them into the stack right after we enter the function sum. Why the fuck would we do that? Okay. The lines move the word pointer RBP -4. Okay, so base pointer. So the base of the stack. Okay. Wait, what? Instruct the CPU to copy the values that are in the registers to the specific memory address location. Note the address arithmetic. Every address is an offset relative to the RBP. Since each integer is 4 byte in size, For each value, the CPU uses an address that is 4 bytes away from the previous one. Note that it is subtracting from the RBP. If you remember, the stack grows downward, okay, from the higher to the lower memory address. This should speak to you. Well, now it does, I guess. Although this does not, but hey. This code utilize the base pointer to save the value of 3 argument pass to the function via register on the stack. At this point, the stack should look like this. We're going to end up doing fucking assembly in here. Create a small C program with only main calling a function, trace as some version yet. It is more obvious when you see it happen. Well, right now I'm starting to understand it, but I don't think if it's going to like answer my fucking question. What's the website for decompile C code? Not that dogbolt? Isn't it like bolt something? No. Code compiler explorer? That will help, right? Yeah, godbolt. Okay. The fucking sun. I swear to fucking god. Okay. So if we do like, bro. Okay. I don't remember jack shit. Oh shit. Why doesn't this work? Oh, sorry. Code in Discord. Okay. Well, don't we see the assembly panel? You do now. Oh, okay. Sorry. Okay, let me just read this. So that's like the opener. Then we do sub RSP 16. So we subtract the 16 from the RSP. I guess that's still part of the opener. Then we move to EDI 8. That's our 8 variable thingy. Then we call this function. We move, we call this function. We create the stack through this. We move at the top of our thing this value. Then we do the addition. Then we move to the result register, right? That's what EAX stand for. It's for like a return register thingy. EAX. Accumulator. Okay. And then we pop. So we go to the base register, which should be this, not the base register, but the base pointer, which should be the base of our stack. So it will clip our whole stack where lol was. So then we can go back here with our new, okay, and the return command. The return command probably automatically reads the top of the stack. It will find that on the top of the stack, or maybe pop does. You reserve 16-bit for Y. Oh, wait, really? I guess I do it through sub, through a subtraction. Oh no, I'm retarded. I'm retarded. Sorry. You're talking about this 16-bit instead of byte, right? That's what you mean. I got it now. Okay, I think I got it. So this is just for us to move the stack pointer. Okay, okay, I got it. So that's like just because it's main, right? Is that the idea? Maybe not. Or is it because we have a variable in the first place? Like if I were to do this. Oh fuck. Wait, I'm toying around. And if I were to like do y equals 8 later. Yeah, the RSP is to move the window at which we work. So we move the stack pointer forward, but I think that the moving of that stack pointer is, yeah, that's just like for us to handle this thing, I guess. It's just because it's main, I guess. But we don't, when we move it back, it goes forward, right? That's the idea. That's what I understood from the explanation earlier, is that we think in our brain, oh, it goes backward. No, because we go downward. Call a new function from lol. That's actually not dumb. The return of fuck J. What the fuck was that sound? Okay. That was a not good sound, okay? Okay. Yeah, I think this is just housekeeping um for the stack itself. So if we were to call another one from there, yeah. Yeah. I think that's the idea. The sub is to push ourselves at the end of this stack. No, not sure. Try a function without parameter. You're a genius. Oh, yeah, that's something that we'll need to try out as well. Could be like int x, um, x equals 1. I control S the fuck out of it. Oh, okay. So here, if we look inside of fuck J still needs to do it. So this looks like, or maybe, let's put this in void, okay? Let's go forward. Ah, shit, I'm returning something. Oh, it doesn't accept these type of shit. Okay. Okay, cool, cool. So, oh, it still does. Yeah. Doesn't make sense to me. I want to see something else. Do we have something with like thread enable? Do we have this? No? It would be the kernel that handles this anyway. It makes sense that we don't see anything. I don't get it. I don't get how thread would be handled here. Or maybe 32-bit. Oh, 32-bit, and we can check if this is still there. Like, do we have, not 32-bit, do we have something that's in, what's it called? 8086. No? You fucking kidding me, bro? I guess that's it. What are we talking about here? What's wrong with that? You need a return? Yeah, I get it, but thread will apply to all stacks because you need to keep the, how does it call? The stack level. That's a new concept. I don't understand what I'm fucking up here. Your second end must be at the top. Oh. Oh, okay. So that might be the issue. You're a genius. Okay, that looks old. Okay. Breathe in, breathe out. Survive. So they still have these things. Oh, wait. No, they don't. That's a base pointer. And the other thing, can we open another one? No? How do I... Okay, cool. Now, how do I go to a real compiler? Which one was the default? Well, fuck it. Oh, if you take a look at fuck J, that's the base pointer. So that's just the thing to call fuck. So that part, essentially, is the part that's happening... Wait, what the fuck? That's the wrong register. Based. I don't get it, but it doesn't answer any question right now of what is the stack structure there. What is the fucking CPU doing? My understanding, my brain's gone, okay? My understanding is that Fred made it so your stack, whenever you, let's invert it, okay? Whenever you add a new thing onto it, you would create here some additional special Fred thingy in here that the CPU was automatically made to like process and have fun with. But right now it doesn't have the space for this. Are we saying that that 8-bit is there for that? Or is this 8 byte? How the fuck would I do that? Like, do they have a debugger? VCC and debug. I don't know what VCC is. VS Code. Oh, okay. Okay. Yeah, all good. Can I just open another project? I'm so fucking confused. Yeah, but I'm confused because I'm sleepy, and that ain't fun. Let's put it that way. Okay, okay, okay. Cool, cool. What the fuck do you think it is, bitch? Um, I don't know. I guess kill me. I'll have to do the thing. I think I'll have to do the thing. Yeah. Why did I use Codium? I'm the last person that needs to fuck with this. What the fuck am I supposed to do? Supposed to do this and start fucking around? Why? Can't it be simple? Where is the other one? What's the name? Okay, develop. Thank you. Do we think that it will have a debugger? Of course not. Okay. Why do I have hopes? Yeah, but it won't. It won't because it's fucking me real. I tried the breakpoints. Can try again. Like it won't because it doesn't actually do anything. Like I need to customize a bunch of shit, or maybe I need to waste half of my life setuping my shit. Is the mean that I don't actually have any of this? Change for VS Code. True. And ironically, I'll do that later tonight. Yep. But I don't think I'm done. Oh what? I was on top chat the whole time? God damn. Hope I didn't. Okay, I did skip a bunch of shit. Sorry. But yeah, I'll do it offline. I'm way too triggered. But I just I guess that's the core of my contention. Is that I don't understand how they're storing the actual information when they're talking about the Fred architecture introduced a concept of stack level. The current stack level is a value in the range 0 to 3 that a logical processor tracks when CPL equals 0. Fred event delivery determines the stack level associated with the event being delivered, and if it is greater than the CSL, than the current stack level, or if CPL had been tree, load the stack pointer RSP from a new Fred RSP SMR associated with the event stack level. Like, how does it do all this? How does it know any of this? Like here, section 3, section 4.3. I guess so. I'm just a retard. I should have read forward. Who knows? New MSR. What do you mean by MSR? Hate not knowing things. MSR. And being sleepy. Okay, those two are a bad mix. Okay. Shit. Oh my fucking lord. Model specific registers. Where was I? Clicking away to find what I had in mind. Okay. How does it even make sense? The Fred architecture introduces the concept of stack level. The current stack level is a value in the range of 0 to 3 that a logical processor tracks when CPL equals 0. Fred event delivery determines the stack level associated with the event being delivered. And if it is greater than CSL or CPL, or if the CPL has been 3, load the stack pointer from a So are we essentially saying there is, in this register, a specific privilege stack that can always be accessed, or at least an address that you can form a privilege stack on? And by the way, you say for each ring, but the technology inside of this is made to only work with only ring 0 and 3. But yeah, like they say range, but I don't believe that it's actually implemented that way. Who gives a fuck? Okay. Well, fuck me, bro. That would make you right. So essentially, those are preloaded stacks for each level to be used. I guess I need to read 5.1.2. Write to any of these MSRs, cause a general protection. Okay, that makes sense. The number 0 to 3 is the MSR's name. Oh, the stack level and not the privilege level. Okay. So stack level and privilege level is a different thing. I'm assuming that we're talking about like level of recursions or something. Fuck. Tomorrow I need to be on my fucking game and we'll need to understand this way the fuck quicker. You know what we need to do? We need to stop being retards and just reading this. Yeah, it seems pretty fucking important. It sounds like privilege and stack level are not the same thing. I don't know. I don't even know what either is. Well, no, I know what privilege, but... Oh, shit. This describes exactly... This is exactly what I was talking about. Oh my god. Bro. Fred Evan delivery save 64 bytes of information on the new regular stack. The following information provides details. I'll die. I just needed to read. The first 8 byte pushed. Oh, we're so retarded. We're so retarded. Could it be that this happens before any of this happens? So it has like no influence on like one or another. All right. I think that's it. Well, one thing that we should check after that. Yeah, it is. I would assume that this is all hardware generated. But here, would it then be surprising to know that the hardware does way the fuck more for a normal stack? There's like oodles of shit, and we just don't know about it. Yeah, it won't be in the compa code. Like, that looks odd. That's exactly not what I wanted to read. Oh, fuck. I guess we won't. So debugging a program that generates an interrupt is the only way to... well, even then, you would have to have a debugger that, like, somehow looks, like, not only at what your code touches, but what is before what your code touches. Like, you would need a debugger made for it, no? I understand that we can go to the machine code level, but if the hardware generates it, you going to the machine code level doesn't matter, right? Because what we're talking about here is like if I'm drawing it, and here I can be a complete retard, right? But like what we're talking about is this is your standard stack, but you are using from here to here, but this is what Fred fucks with. So why would your debugger look at all of this when in reality, what it usually looks at is this? Because this is not the stack. It is like the pre-stack. It is an hardware generated pre-stack. So unless there's always been a pre-stack, and when we go and take a look at it, it will show us. Okay, the stack is a blah 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 blah. Debugger can look at all memory if it has the right to read the memory section. I guess yes. I'm just saying that your debugger would have to know where the fuck to look at, and I don't know if your standard debugger would, like by default. Okay, can we? Okay, is this talking about the like what would be in between the parentheses here? I hope. Yeah, because when we're saying this, this would be referring to an int declared inside of a function. That's my understanding. Local variable for calling procedure would be that. I would have agreed with you, MB, but why does the output here looks like this then? Wait, isn't that retarded? Why would we look at the first call? Yeah, main. We move it to EDI then we call, but then we also copy over EDI to a place. Why do we do that? Isn't that a waste of time? Like what I'm not understanding, you use EDI for the return value. There must be a reason why the compiler does this, because this feels crazy retarded. Like, why wouldn't I just... Yeah, I'm saving it. Oh, because we're reading from here and putting it there. Okay. No, it can't. I cannot be right. That's too retarded, right? You cannot have, like, you move EDI... Wait. In which order is this shit? It doesn't make sense anymore. So when we move this to there... Wait. Is that housekeeping? That's housekeeping. Fuck. Main. We move 8 to EDI. That's the order, right? And then we call lol. Then we move EDI to the word pointer disposition. We add 1 to it, and then we move that thing back into EAX, and EAX back into EDI. That's retarded. Why wouldn't we just leave it in EDI, do add 1 directly on it, or whichever the fuck is the addition, there's no way that it is that brutally retarded. Are you telling me that I could? Assertions. What does that mean? Well, clearly they didn't do better. See a slow write assembler. Based. Why is it worse? Nah, bro. It must be in retarded mode. Like dash O, is it something special or... Oh, no. Why am I doing this? We don't care. Okay, compiler option. Oh my fucking god, you stupid shit. Isn't that... Yeah. May increase code size, my ass. Oh. But yeah, look, it's at -1, it's doing exactly what we were talking about. Well, I guess... Wait, it's not even calling it. I guess I would need to int this and put x to it. That would be like more akin to... Okay, okay. Yeah, I didn't give a shit, but yeah, it was just that our compiler was not optimized. Stack alignment. I guess what we were looking at was just a clean way. Hi, Ion. You must be new. How's it going? Sadly, we're done soon, but we'll be there tomorrow. In the morning, though. So when they say here, a calling procedure should explicitly save the value of any of the general purpose registers that it will need when it resumes execution after return. I guess that's what we were seeing here whenever we didn't have this, right? They're technically using the right procedure by, like, saving a bunch of shit. Good, just finished working on patch series. That's great. Patch series on what? Probably your job. But right here, you're talking to Master. Dumbass. That doesn't know anything about anything. Linux kernel BPF. Oh, goddamn, we got some big baller over here. It's not an insult, it's positive, my friend. Happy that you're here. Trying to learn things over here to do the kernel research. But yeah, BPF looks interesting. I'll need to read more on it because right now, whew, it's my knowledge is weak there. Okay, I'm vibing it whenever I make my videos. So I'm trying to not push too far. Yeah, I don't know if I'll get an answer to my question here. Oh, wait. Oh no, it's shadow stack. Okay, that's why. Sam is selling. Sam is selling strong. It's like, join the Discord, please. I love you, Sam. You're selling so strong, and I love it. Oh man, it's talking about. We are not a sect. It's not a cult. We have a lot of chaotic neutral dumbasses. Oh, I'm so dumb. I think I get it. Wait, I'm thinking about it. When there's an exception, right? We're going to slap the top of the stack with a specific code. So it's probably the same principle that they're using for their thread event delivery, and we don't need to look into it further. But you're right. It's probably only for, it's not for all stacks. That would be dumb. Okay, I don't get it. Join the call. I'm reading shit, okay, I swear. I'm not looking at only the pictures in order to try to get knowledge. But Fred use other register to store temporary interrupt stack. But the information is on the initial stack or on the Fred stack. Okay, so just to address the two. I don't think we're, fuck, my mind is cooked. The thing that we're working on right now, I'll talk to Ion because I don't even know if I can address what you wrote, MB. But we're working on understanding how Fred work, how Intel, well, it's not Intel anymore, I guess, but how the Fred, so flexible return event delivery system of Intel. And the thing that we're trying to understand is how it fixes everything that it fixes. So the fix that it does is it doesn't wash away two of the registers that like normal events and interrupts and these kind of thing would. So the explanation that is offered in the documentation is shit is added onto the stack. But the problem is that reading the documentation, it will also say, well, you now have some magical registers that are added, 4 of them in fact, that are related to stack levels, not privilege levels, but stack levels. And I'm just trying to understand what the fuck is the link between all of this? So where is the information stored? What the fuck is a stack level even? Like, yeah, I don't think that there's anything you could chat and that would help there. But anyway, I'll have to read more. But yeah, we're beating ourselves to understand the basics and at the same time, Fred. Yeah, that's all for today, okay? That's all for today. Thanks for tuning in. Thank you for being there, Ion. And thank you for graciously offering your help. But yeah, if you know things, the Discord server and a live conversation would be cool. Yeah. I'll be streaming tomorrow. I don't know for y'all, especially Ion, the time frame here, but I'll be there tomorrow at what time? Should be there 9:50 Eastern Standard Time. So if anyone want to join, I'll be researching the same freaking shit. So yeah, you know what? Let's log in all of those things. Okay, let's star all of this. Don't believe him. He won't even be there. That's true. I'll join the call. This look interesting. Just for my understanding, did you find this because of the kernel and because of the kernel review video, or because of just a stream on the corner of your YouTube? That's important for how I'm going to speak. Yes, kernel review videos. Okay, we're good. We're good. I would have been surprised otherwise, but wanted to be sure. So yeah, we're working on that right now. But you'll see, I don't know anything. All right. That's all for today. Love you all, guys. Be there. I'll be there tomorrow if you want to be there. Cool. Or political interest. Political interest. We yap politics when I get too sleepy, okay? I'll be there tomorrow, the day after, and the day after, and the other day after, because I'm always there. But if you want to catch me late like today, it will be in 2 days, because that's when I work. Anyway, bye-bye. Love you all. Bye-bye. Worship Maple? No. Mark Joseph Carney. True! Okay. Bye-bye. Bye-bye. Love you all.